Hi everyone, welcome back to Sciencelemst. I am Miss T, and in today's video we'll be solving this hydraulics question step by step while looking at the core theory. It states a force of 350 Newton is applied on piston A. It's applied on piston A, which has an area of 0,020 meters squared. So the area of this piston is that. Piston B has a radius R of 280 millimeter. So the radius of this piston is 280 millimeter. We don't have the area, but we are able to calculate the area. 6.1, define the term thrust. So in a hydraulic system, we have to apply a force. So this force that we apply here, it is considered to be what we call effort. That's the force that you are exerting. So this force that we are exerting here, it generates pressure within the fluid that is enclosed within this container. This pressure that is generated within this fluid creates or results in an upward output force that is going to lift piston B. So again, this force that you exert, which is your effort, creates a pressure within the enclosed fluid that results in an output force that actually pushes the load, because this side, this is where the load is that we want to lift. So this output, this force, the output force that is generated by the pressure in the fluid, it is going to be acting perpendicular to the piston. And that force is given the name thrust. So you apply an effort on the cylinder. The cylinder presses down, creating a pressure inside the fluid. This pressure is transmitted equally, and then this pressure pushes the piston up by doing what? By generating a force that is going upward, that is called a thrust. So the pressure buildup here generates a force here that lifts the load up, and that is called the thrust. How can we then define it? Thrust is the normal force exerted by a liquid at rest on a given surface in contact with it. So this liquid here, it's not moving. It's just standing still. Hence we're saying it is at rest. I hope that's clear to understand. 6.2. Calculate the magnitude of the force exerted on piston B. For us to be able to answer this question, we need to understand something. Hydraulic systems work on a principle that's called Pascal's principle. Pascal's principle is telling me that in a continuous liquid at equilibrium simply meaning this liquid is not moving. So in a continuous liquid in equilibrium, the pressure that is applied at any point, it is transmitted equally to other parts of the liquid. Let's repeat it again. In a continuous liquid at equilibrium, the pressure that is exerted at any point, it is transmitted equally to other parts of the liquid. With that said, it means this. For 6.2, I am applying Pascal's principle, and Pascal's principle is telling me that P at A is equal to P at B. That's the information I'm getting from the principle. And I know that pressure is calculated by force over area, meaning this side is going to also be force over area. That's me applying the principle that the hydraulic system is working on. So before you do any calculation, I need you to collect the data. So let's collect. I have force. So everything that's given, my force A is equals to 350 Newton. I'm also given the area is equals to 0,020 meter squared. Guys, this is a 2. I hope you see it. I'm also given radius B is 280 millimeter. That's the information that I'm given. Someone might ask, what about this distance? That distance has nothing to do with the calculation. Remember, the calculation we are referring to is the pressure is equals to force over area. So in my calculation, I just need the force and I need the area. So I've collected the given information. So what is unknown? What is unknown is force of B. But also on that note, area of B is also unknown, but I am able to calculate it because I am given the radius. So force of B is unknown and also area of B is unknown. So now to calculate the formula F that I need comes from Pascal, remember? So it is going to be force of A over A of A is equals to force of B over A of B. Note, my labeling is given as piston A and piston B. That is why here I have force of A over area of A. If it was given as piston 1 and piston 2, I would have written force of 1 and area of 1, force of 2 and area of 2. So pay attention to how the labeling is given on your sketch. Then we do the substitution. So substitution S. So S stands for substitute and then solve. So substitute 350, the area 0,020, the force that side that is unknown over. Now here's the thing, we don't have the area. We have to calculate it. So the shape of our piston, it's what? Let me see if you know. Please comment it. So to calculate the area, we're going to say pi r squared. Okay. So now there's no need for me to write the formula there. I can just go in and do my substitution. But here's a catch. The radius that is given in millimeter, and that is not an SI unit. So I need to convert it. So I need to move from a millimeter and go to a meter. To do that, I need to divide my value with 1,000. So I like doing it within the calculation. So if you have a problem with doing it within the calculation, that's fine. You can do it on the side. But remember, do not round off while you are doing the calculation. We only round off the final answer. So whatever value you're going to be using from the outside to do your calculation, it must not be rounded off. So this side I'm going to get 17500. It is equals to FB over, it's a long number, 0,246 300,864. Okay. So at this point, you can choose. Either you multiply both sides with the value of the denominator, or you cross multiply. So I'm simply just going to cross multiply. So divide by 1, and I'm going to get FB, it's equals to 175 multiplied by 0, 2.246300.864. And then my final answer is 4310.27 Newton, and it is going up. I hope that was clear to understand. 6.3. The 3-meter distance between K and L is reduced to 1.5. So this is no longer 3 meter, but now it is 1.5. How will this change affect the pressure of the system? Write down only increases to decreases or remain the same. So the answer in this situation is going to be remain the same. So why am I saying it's going to remain the same? Remember, pressure is equals to force over area. So the pressure that is exerted here, that is exerted within this fluid, within this liquid, it depends on the force that is being exerted in the area. So this distance here, when it reduces, it's not affecting the force that is being exerted, and it's not affecting the cross-sectional area. So this is why I'm saying it will remain the same. If we were changing the force or we're changing the area, then we will say something. Because look at this. Because the force is on top, the force is directly proportional to the pressure. So if the force is going to increase, then the pressure is going to increase. If the force is going to decrease, then the pressure is going to decrease. But now if I look at the pressure and the area, the relationship between the two, they are inversely proportional. So if the area increases, the pressure decreases. And if the area decreases, then the pressure, so they are inversely proportional. So those are the only two things that affect our pressure. And remember, Pascal is telling us that the pressure is transmitted equally, regardless of the length that it has to travel, or regardless of the distance that it has to travel. 6.4. Write down one use of hydraulic system in technology. So there are many. There are many that you can write. Hydraulic car jacks, hydraulic lifts, used in workshops, braking systems in vehicles, heavy machinery like excavators and bulldozers. With tech science, they never really ask you to explain them in detail, but my next slide sort of kind of like explains it for you guys to understand them. So these are the applications of hydraulics in technology. They are used in heavy machinery and construction, like your hydraulic jacks. You know, when you lift in the car, when you want to lift the car up so that you can take out the wheel to change the tire. And then it is also used for automotive and transportation, like your braking system. So for your brakes to work, they're using hydraulic system. And they're also used in industrial manufacturing, like hydraulic presses. It is also used in aerospace and marine, like your aircraft controls. It is also used for emergency and rescue, like the jaws of life. I hope you enjoyed this video. See you in the next one. Please don't forget, science is enjoyable. Don't stress it.